Okay, so polar slope and arc length. Okay, so slope in calculus never changes, right? So even in it's always dy dx. Okay, so we went through dy dx in the rectangular plane, and we did it with parametrics, right? Parametrics, we had to figure out what was our parametric slope? Remember the formula, top over bottom? What was it?
Was it dy dt?
Very good. Got it. Right? Because parametrics are in terms of time, right? Well, what factor are polars in terms of? What? Yeah, theta, right?
So it's going to be dy over dt and then d theta.
So polar is dy d theta over dx d theta.
What if we had a parametric polar though? Do they have that?
What's not? Parametric polars?
Yeah.
I don't ever remember seeing it. I would not doubt that someone crazy did something like that, but I don't remember ever seeing it. So.
Well, it would just be like a clock or whatever.
Okay. Do you remember how to convert? So y was r sine theta, right? And to convert polars. So we need to implicitly differentiate r sine theta to get the top of the fraction. Okay. So I'm telling you how we came up with this. You can just memorize the formula at the end if you want. But you already have this memorized, and this is more simple. You can derive it every time if you want. Right? So this is a product rule, right? So what's the derivative of r with respect to theta? It's 1 dr d theta. So derivative first, copy second, and copy first. What's the derivative of sine theta? Okay, there's your top of your fraction. Okay. So we've just derived that y equals r sine theta to get the top. Okay. What is x equal to? Yeah. So we do the same thing with that. We derive it. So again, dr d theta cosine. What's the derivative of cosine? Negative sine, so it's going to be minus r sine theta. Okay. So again, we derive this. You can memorize this mess if you want, or you can just memorize what you already have knowledge of and derive it. I don't care. Whatever floats your boat. Okay. Personally, didn't have this. I don't have this memorized. I just think of slope as dy dx. That's my container for slope, and I know that parametrics is dy dt, dx dt, and I know polars is dy dx, or dy d theta, dx d theta. And from there you can do it. Okay. It just keeps it more simple in my little bucket there. Right. So there's the slope formula for polar. Yeah, it's a mess, but it's not that hard to work with. So what if we want to find an equation of a tangent line? So we're going to find the equation of the line tangent to the polar curve. R equals sine 2 theta. That's ugly. And theta is 3 pi over 4. Remember, oh, do we need R? Right, so R is sine 2 theta. So sine 3 pi over 2. Sine of 3 pi over 2 is? It is. Okay. So we have our point, right? But what you have to remember is we're in X. To write the equation of a line, tangent to a curve, we're still going to be in rectangular form. Okay, so we still have our same old, it's kind of confusing a little bit, but it's kind of nice at the same time. You write your line in the same form every time. Okay, so from our polar coordinate, with these, we need to figure an X and a Y out, right? So X is -1 times cosine 3 pi over 4. Should be, this is -√2 over 2, right? Yeah, so this whole thing is √2 over 2. Y is our sine theta, which is -1 times sine 3 pi over 4. So that's going to be -√2 over 2. Okay. All right, so we have our X and our Y now. Oh, I wrote, what? Yeah, I think it's right. Okay, all we need is our slope, right? So we've got our messy formula, and I don't have it memorized. Whew. Arm's getting tired. Okay. So again, if you want to memorize these, writing them down every time helps a ton. All right, so plug your values in. what's dr d theta, first of all?
Goes up and down, isn't it?
It's right there. Right. So we're deriving this. Okay, so that right there is what we have to derive here. So what is the derivative of that?
2 cosine, 2 theta.
Yep.
And then carbon.
Top and bottom. Okay. And we still have sine theta. Oh, that's not a parentheses. It is a parentheses, but it shouldn't be there. Whoop. Sine theta. That's our cosine theta. Great timing. All right. Now you can plug your values in and get the slope. Yeah, not hard work, just kind of a mess. You lost anybody? Okay, you still with me? Good. All right. So plug your values in. What's 2 cosine 3 pi over 2, and then sine 3 pi over 4 plus -1 times cosine 3 pi over 4.
Would we have to do this by hand on the AP test?
If it's this, you could. This is a unit circle problem. It's just a lot of work.
Thinking.
Now, do you have to write all these steps down that I'm writing down? No, you don't.
Yeah.
Do you want all the figures?
All right. Cosine at 3 pi over 2 is 0. Right? 0. Don't have to worry about this one now. And then cosine at 3 pi over 4 we've already determined. That's a -√2 over 2, right? So times -1 we get √2 over 2. Again, 0 plus √2 over 2. What's the slope? All that work. That's kind of funny, actually. I think it's funny. Okay, so what's our equation?
It's going to be in the first value equals x minus √3. So up there, those are your points?
So yeah, this is my x value and my y value, right?
Okay.
And then my slope. And there's your line. Boy, howdy, that's a mess. No. Think this through. Graphically, this is the 4-petaled rose. Right? 3 pi over 4 is right here. Your slope is 1.
It's on the other side.
No.
I just graphed it on the calculator. What we calculated is the slope on the fourth quadrant at the end.
Here?
Yeah.
Which is what?
Yeah, you're right, actually. You're right. Because that point, see, √2 over 2, negative √2 over 2 puts us here. So, huh? Yeah, slope's the one, but graphically, there you go. Again, thinking through those angles, I tend to think in unit circle, and that's what made me this error. So think in terms of where that point would sit on this curve. 3 pi over 4 is right here. Okay, because the radius is probably negative something. Okay, so that's slope. You're like, that was awful. Was it hard though?
No, it's just
It's
time
just-
consuming.
It's just stay organized, use the formulas, we're good to go.
Just do calculus, it's not that hard.
It shouldn't be that hard anymore for us, but I mean, your thinking in terms of polar coordinates is different. It just changes your mindset a little bit. So. Okay, arc length. Very similar to parametrics. Look familiar? So basically you're going to be given a curve. You find the endpoints, you plug in the derivative and the original and get after it. Okay. Again, they'll either ask you for the setup to check to see if you know how to set the problem up, because the calculus, they're testing in other parts of the test, or it will be a calculator-friendly problem, or it will fall out really easily. Okay, the example in your book uses sine squared plus cosine squared is 1. And then it just falls out, the root falls away. So, do you want me to show you an example, or? Yeah, okay. Let's find the total length of the circle.
Are we gonna make more cards?
Yeah, tomorrow. The plan. R equals 2 cosine theta.
On the AP test, will they just say it's R equals 2% theta, or will it say it's a coordinate or a polar problem?
Well, it's obviously a polar. R and theta. So the no.
But they won't have any cryptic questions with that kind of
No, they're very straightforward. Yeah, sometimes you have to think through what to do with the polars, but it's very obvious.
Will we ever have to move them to like next slide?
Well, only if you're doing a slope like we just did in terms of x, y, but
That's the only time we got.
you might have to convert from polar to rectangular in some way, shape, or form. But okay, can anybody think of the easy way?
Circumference.
Yeah. What's the radius?
2% theta.
It's 1. Remember when you graph those, this is 2, right? Yesterday we did 4 cosine theta, the radius was 2, right? So be careful, but this is the easy way. Like we know the circumference is 2 pi, done, right?
So, will they ever like want you to, because sometimes they give you points for setting it up, if you set it up that way, and it required you to set it up.
I don't think they would put a problem like this on it. If they want arc length on a free response, it's probably gonna be like, find the length of one petal of sine 2 theta. And you'll have to, you'll actually have to do it calculus-y. But, I mean, if they do, have at it. It's not incorrect math. And they'll give you the setup points and stuff. So. All right, so we need our integrand limits. Again, the most challenging part of these. Does that circle go from 0 to pi or 0 to 2 pi? Or we could do half of it and multiply by 2. Doesn't really matter, right? So if theta is 0, our radius is probably 2? Correct? What if theta is pi over 2? What do we get for r? And what if theta is pi? Okay, that completes one loop of our circle. Right? So we got here 0, 2. You come back to pi over 2, the radius is 0. And if you go to pi, the radius is negative 2. Right? So we have just completed one circuit. We could do pi over 4 and 3 pi over 4. They would give us these values. Okay. Do you understand how I got those? You two look a little stumped.
So basically what you're doing is like turning this just on the upper side of the graph, like you're calculating it that way, and that's why
Right,
it's
that-
2 to negative 2.
Yeah, the angle theta does still rest here. Pi is here, right? 1/2 of a revolution, but the radius is negative 2, so it comes over here. Right, so you complete your whole circle on this side of.
So since you're tracing from the line and you don't go by the origin, you don't start at the origin when you're doing that?
Well, it's a normal unit circle style analysis.
Right.
It just gives you a negative radius and leaves you stay over here. Right. Okay, so yeah, so our integral is from 0 to pi. F prime at theta is negative 2 sine, right? Sine theta. Okay, there's your setup. This one we can actually finish by hand, I think. Okay, you with me on the setup? So most of the time, again, it's going to be just set this up and it's done. Or a calculator, but this one we can finish. That's 4 cosine squared, right? 4 sine squared.
That's negative 2 sine theta. Second part, right?
Yeah, but negative times a negative is a positive.
Which one's this?
Negative sine times negative sine
You're squaring it.
is positive
Oh, but like
sine.
in that first setup, that should be negative 2 sine.
It is, well, it's 2 negative sine. Anybody remember what sine squared plus cosine squared is?
1.
Yeah. So we take a 4 out. So what do we end up with out the end? 2. You got 1 here. And then the square root of 4 is 2. I'm kind of going fast for you, huh? And you got your integral, which turns out to be really easy in this case. Yeah. I would not surprise me to see this identity used on the AP exam, but you know it. But that's, I think, about as far as I'll go. Anything else is gonna just be calculator. So this is 2 theta from 0 to pi, which is 2 pi's. And we just did it the hard way. Congratulations.
That's the hard one?
Well, the easy way is to do circle circumference, right?
Depends on the- So what's the tangent? We haven't seen tangent.
What?
What about tangent?
What about tangent?
You haven't shown us that.
The function tangent?
Yeah.
In polar coordinates?
Yeah.
I don't know.
It looks like
Fire it up on your calculator.
It looks like
You
an
piqued my
hourglass.
interest.
it looks like an actual hourglass.
No kidding.
Like, and even has like the it's just
Oh yeah, that's where tangent is undefined.
and there's
At negative pi over 2 and pi over 2?
So we won't have to do this?
I doubt it. Okay, 25 through 29 odd, 31, 37, sorry. It's on here. And then AP 7 FR1, AP 8 FR1. And guess what? Congratulations. Last day BC Calc lesson. We still have a month and a half, but that's your last lesson in BC Calc.
Should I remind
So
you?
visual relief. Yes, you will still have homework, but it's not going to be as much.
That means we're not learning anything new.
No, this is all of it. We're done with all the new material in BC Calc.
So for our review, are we just gonna focus on DC stuff, or are we still gonna do some?
Well, you're still going to practice AB a little bit. I'll give you a free response from AB every day probably, and BC. So we're going to do both. If you can earn a 5 on the AB section of the test, you're pretty much guaranteed a 3 on the exam, right?
That's what I'm relying on.
But then you get the BC part, the better you do, the better your score is going to be. So, yeah, we'll still work on what we know,
Got some work to do.
get better at it, work on what we...
I have so much.
I-